Alrighty, so we're here to find out what is SLSA, supply chain levels for software artifacts. All right, you know what it is now. We're done, right? Okay, maybe not. Let's start with what is a supply chain? I'm sure you all actually have an idea of what this is because we had problems with it the past few years, and that's why everything got super expensive and delayed. But basically, widgets, any widget, has a supply chain. It includes the original stuff that gets refined, the creation of each one of the components, the assembly of the components into subcomponents, the subcomponents into the actual widget, the transport, the sales, the retail, yada, yada, yada. With software, it's the same idea. You're taking these different pieces of software, open source dependencies, and they get bundled up into some proprietary stuff which gets put into a package. Then somebody else is like, I'm going to take that package and OEM it into my package. So you've got the same thing going. Why do you care? Well, I'm sure we've all seen this XKCD comic, yeah? Upwards of 50% of the code today that is being used is actually written by somebody else, by a third party. Usually it's open source. This means that if one open source component gets compromised, everybody who used that gets compromised. So everybody remembers the Okta issue, the PyTorch Torch Triton issue. There's been a lot of fun supply chain security problems lately. All right, so what's SLSA have to do with this? I'm gonna have some Tostitos while I do incident response? Well, it was started by Google. Google seems to have an obsession with food. They've got a new thing called guac that goes with SLSA. I don't know. They're very hungry, I guess, because they get all that free food. And it is now actually owned by the OSSF. We're on version 1. It actually took a really long time to get to version 1. Well, okay, great. What is it? It's a checklist. It's a framework that you're going to use to try and prevent tampering, to show integrity of these packages and the infrastructure that the packages are built on. It's how you know that you're safe enough. Nothing's ever going to be safe. If anyone tells you it's a silver bullet, it's 100%, they're lying. Don't believe them. Run the other way. All right. So what parts does it care about? We divided it into 3 tracks. Build integrity, meaning you are building this software on what? Are you building it on Bob's computer? Does Bob have an antivirus? What happens if Bob gets sick? What if Bob clicked that link in his email? Can you reproduce it? If Bob's doing this bespoke process, how do you know that build 1 is going to be the same as build 2? It's better to have a dedicated machine or dedicated infrastructure to do these build processes so that it's replicable, so that you can kill it and spin it back up again, and that hopefully that new spin up doesn't have whatever terrible thing somebody downloaded onto it. There's also the source integrity track. Hopefully anyone here who's doing code has 2-person review. Maybe in your GitHub, they require you to have some kind of security key, a hardware key, or at least be signing your commits. These things help with source integrity. It means somebody can go back in time and look. And if you know somebody got compromised, you can see, okay, well, what were all the commits by that person that was compromised? Let's double check them. Let's see if there was anything fishy in there. And last is dependencies, the thing that we were just prattling on about, is what you're bringing in. Is there some kind of checks that you're doing on them? Do you have SCA tool? Do you have SLSA verification? Is there something you're doing to make sure that you're not just YOLOing it? All right, so we've got those 3 different tracks. Within the tracks, we've got levels 1 through 4. Hopefully that's readable. Yeah, good enough. So this looks a little complicated, but it's the simplest we could come up with. And basically it says, if you're level 0, you're not even trying. If you're level 1, you've at least documented what's going on. 2, you've provided some tamper resistance. 3, you're actually targeting specific threats. You've got a pretty good, amount of stuff going on to protect yourself. And 4 is the highest level of confidence that you can have. Again, that does not mean 100% safe. It just means you're fairly confident. If something happened, you could detect it. And so this is a progressing integrity guarantee. And it also gives everyone common language. I'm sure everybody knows at work when you say the word service or secure or whatever, means something a little bit different to everybody. Or vulnerability. Have you ever gotten into the fight about that one? Like, this one's a high. No, it's not. So when you have a common language, at least you can be like, per this standard, per this framework, we're this. We may not agree with that, but at least we know we're talking the same thing. By the way, all the slides in my speaker notes have references to where all of these images and things came from, and I'll make it available at Twitter or whatever the hell it's called now afterwards, and so you can find it there. All right, this one is a little bit complicated, but like, how do you figure out which one of those levels you are? This is not something where you can just do one of the things in level 2 and you're like, boo, I got level 2. No, you either have to do everything in a level. You can bonus points do some of the stuff in the next level, but you don't count as that level. And so this is the checklist for the build track that we were talking about. How do I know which level of the build track I am? Great, Nicole. Where's that source track and the dependency track? We haven't written them yet. So if anyone wants to join the working group with me, there's details on that later. If you've ever had a group of people all trying to decide how you get multiple different industries to cooperate and agree on the thing, you know it takes a while. So anyway, at least for here, let's give an example. What do I mean by provenance generation exists? So provenance means, where did you get this from? Did you just like pick that dependency up off random repo on the internet, or did you get it from PyPy? You're documenting where this came from, and then ideally, it documented where it came from. So you're trying to track it back through this supply chain. And we're talking about producer. So as a producer, can I say that I'm following a consistent build process? Can I say I use GitHub and I use this CI/CD process, or I use GitLab and I use this pipeline configuration? And so in the future, if I want to replicate this, I just pull out GitHub or GitLab and this config file, done, replicable. Now, the interesting thing here is for level 3, you've got to have it isolated and hosted. Right now we have a little bit of an argument about the word hosted because people seem to think, and we agree with them, that hosted implies you have to like host it on somewhere. You could actually self-host, that's fine. We're trying to come up with some better terminology there. But it just means that we don't want it to be, Jane's laptop. We want it to be a dedicated system that is isolated. You don't need to go as far as air gap. Air gap is a pain in the butt. Been there, done that. But do you have a firewall around it? Can you prove it's not randomly calling out to the internet? How many malicious dependencies can you detect? And the answer is a lot. By just looking for, when you're building your process, is that open source dependency calling out to the internet to try and grab something? Is it trying to grab something that's typo squatted? Looks legit, it isn't? Or is it trying to grab something not from a package manager? That's super sus. So instead, have a local proxy cache, build everything in isolation so you know exactly what is being built and that you've scanned all of that. So that's why you get into level 4, being the most trustworthy. All right, so what does it do? Well, it's not, SLSA is a framework. It's not going to detect a CVE. It's not going to detect that you leaked a passcode. It's not going to detect that you have a key leaked. It's not going to stop insider threat. But it's going to allow you to set up some extra rules in your CI/CD process so that you can get earlier alerting to, I wasn't able to tell where this came from, or this did not come from a trusted source. This is something worth looking at. It may not be a problem, but you should take a look. So it's giving you extra rules and policies you can put in place. And it's also really handy for incident response. How many people here have to respond to something and be like, okay, when did this thing go wrong? What got introduced? Well, if you've got really nice records of all the changes to your build system and where you're grabbing everything from, well, I mean, when you figure out approximately it was between X and Y, let's look at all the docs there, right? All right, so SLSA recently changed from version 0 to version 1. If you did version 0 or heard about it, what's kind of the differences? Overall, 1 is more stable because we kind of lowered our expectations. It sounds bad, but it's actually good. We were aiming for like really good build systems, and we're like, nobody's gonna get there. This is not gonna help anybody. So less ambitious, but way more stable and achievable. It also corresponds really well to the provenance requirements that we had dug through in version 0. And so what I was talking about, like tracking things back through the chain, which gets into the whole guac thing, which I'm not going into in this talk. But you can look it up, GUAC, but then put minus guacamole, otherwise your search results are just not going to help you. We also deferred some of the level 4 stuff as like, if you want to go for it, but we're not going to spell out exactly how to get there because most people are going to struggle to get to 3. All right, so again, key changes. We made the levels into different tracks, build versus source versus dependencies, so you can focus on different ones instead of having to do everything all at once. So you could say, well, I'm a build 3, but I'm a source 2, for example. And then we added some guidance around doing the verification. So before we focused on making the documents, version 1 has a lot more stuff about verifying the documents. And then finally we updated some of the schemas. If you are actually producing the schemas and not using a tool, there's a lot more clarity of exactly what we want in there. Why did it happen now? Governments, that's the answer. They're the problem, right? Well, in this case, they're actually trying to help everybody out. U.S. government put out EO 14028, European Union Cyber Resilience Act. Canada did C26, but it's mostly for the telecom industry. Maybe we'll get an update that expands it. Germany Cyber Resiliency Act, clone with a different name. Basically, everybody is coming up with stuff because everyone has noticed this is a problem. So even if your particular industry doesn't yet have something saying you have to follow this, it's not the worst idea to follow it. It's similar to SBOM, and in fact, you can use SBOM as a piece of your SLSA documentation for, again, saying, what is my source, where did it come from, etc. Just use an SBOM. So, you know, why not? All right, so software development lifecycle. Hopefully you're all here because you do software development, or at least put software into your stuff. What does software look like? Well, if you sum it up, it looks kind of like this. Somebody writes some code. The code goes into a build system. The build system grabs some dependencies. It packages it up. Somebody uses it, hopefully. If nobody's using it, maybe you're a startup. Anyway, and that comes with all of these problems that are kind of sorted out into these 3 sections. And so you can see at each one of these areas, there's the potential that somebody can compromise something. So, all right, how is SLSA actually going to help this process? Well, and this is going to seem like a really weird segue, but just hold on a minute or two with me here. If we produce these artifacts that I've been blabbling on about, and we've got these attestations, here's the pieces of them. And all right, let's hopefully, right here. If we start over here, the predicate, AKA where'd this crap come from, goes into a statement that says, hey, I include all these different predicates, which goes into an envelope which says I built into this. And here's how I built it. I used GitHub. And I use this CI/CD, and I did it at this time, and then, by the way, here's all the stuff that went into it, and then I sign it. And then if I've got a lot of dependencies in my project, I bundle them all up into a JSON bundle format, and then I can put this either along with the package that I'm deploying, or if I'm putting it into a package registry, NPM, and I think PyPy now have support, you can upload it with your wheel, your cargo, your whatever. So there's multiple different ways to send it up. Currently, the recommendation is to use in toto attestation format. In toto is its own format. We just said, hey, it's really handy, why don't we use it? It's just a JSON format. It's not particularly exciting. It's just a specific set of key values where we say like, hey, can you tell us what time you started the build? Can you tell us, you know, what build processes you used? You did it on this Docker container or whatever. And then the other thing is for your predicates, you can, like I said, include an SPDX SBOM. You could actually, you don't have to use these formats. You can invent your own format as long as who's ever consuming it is happy with it. So if you just want to like put it as a text file, cool, put it as a text file. The whole trick is, can you actually go back and look and be like, what was in there? What did I do? Because we all remember SolarWinds and the DLL changing, so if you hash of something saying like it should have been this hash, maybe you would have got an earlier warning. All right, so we created these documents. That's great. We published them. We either put them into PyPy or we send them out with our bundles, and they're signed so somebody can verify that they're actually legit. So now I'm the consumer. I'm going to say this. Hopefully I say it again somewhere in here. We trust build platforms and we verify artifacts. So for the build platform, there is not going to be an automagical way that somebody's going to let you audit their build platform system. It's not happening. On the other hand, a lot of times you probably give a security assessment to your vendors, right? A lot of the stuff for the build process is actually already in most security assessments. So you can be like, you know what? I trust ActiveState. I trust Google. I trust this person's build system. I trust that they are doing two-person review, or they say they are, or an auditor went through and said that they are. So now that I trust these companies, if those companies sign the attestation, I believe in their build system. Everyone has to take a leap of trust somewhere, and that's where you're going to take that leap of trust. Now that I trust these companies, I can say anything signed by them, when it comes into my process where I'm deciding to use that dependency, where I'm deciding to OEM this, I'm going to check the signature, and then I'm going to crack it open, and I'm going to see, does the hash match? Does the number of files that I'm supposed to get match? And if I want to go as far as that, does the SBOM match? Does everything it says I'm supposed to get, is that exactly what I got? So now I can actually put in a check during my build process to verify the artifacts and the files that I'm getting. You can't verify their build system, but once you trust it, you can trust those signatures and go from there. And I forgot to mention, there's tools like SLSA Verifier that are out there. There's other tools that are out there. You do not need to invent the verification software yourself. It's already there. So we've now fixed a bunch of these. We've fixed C through H, being that we can just check things. Hopefully your SCA tools, your CI/CD tools, start building these in the near future. Maybe if you have a feedback button, you could be like, hey, I want to start doing this. Can you please support this in the near future? So, I mean, you've still got problems with your source code. But if you're following secure software development practices, two-person code review, multi-factor keys, you probably have a pretty good degree of trust in your source code, hopefully. And then if your build system, if you're aiming to have a nice build system that's hosted, remember you can self-host, with a replicable system that you're scanning and you're updating and you're patching on a regular basis, you've got a fairly trusted system. Maybe you're actually tearing it down and rebuilding it constantly so that if it does get compromised, it's a little bit harder for it to stay compromised. Then you've actually got a pretty hardened system. All right, so I talked about all these tools that you can use. Let's go into some specifics. Testify Sec Witness is agnostic. They do have a paid version, but they've also got an open source version. These guys are very nice, and if you tweet at them, they'll probably actually answer your questions. Although they might prefer if you just put in a question in the GitHub project. But anyway, it's pretty agnostic. They wired it up to work with GitHub and GitLab. They may wire it up to work in other systems if you ask them, or maybe if you try and help out. Google Cloud Build supports SLSA. GitHub Actions supports SLSA. GitLab Runner supports SLSA. So, I mean, if you're using Bitbucket, I don't know what to tell you, other than Bitbucket, you know, maybe you want to use something else. Anyway, maybe you can get Testify Sec in there. And then, all right, you've got all these documents being built for yours. You want to be able to verify all the stuff coming in. That's where SLSA Verifier comes in. Some of these other systems may also be able to support these policies. Again, use your feedback, ask them to be able to do that. You can also write your own if you want, but it's annoying mostly. It's not actually hard. It's taking a signature, verifying the signature, calling. It's like checking keys on HTTPS. So if you've done that, you could totally write your own. Some package managers like NPM support this. There's other stuff that is soon going to support it. If you want to use a vendored solution, I work at ActiveState, we do that for you. So yeah, you got tons of choices. All right, how do you get more involved? If you're interested in frameworks and you're interested in protecting dependencies in your stuff and everybody else's stuff because you don't want to deal with log4j crap again. Well, the OSSF has a supply chain integrity group, working group specifically. You can go to our GitHub repo. There are open issues, and they basically say, hey, you need to define hosted better because it's confusing people. You can just go ahead and you don't even have to be a member of the project. You can be like, hey, I think this word would be better. Or I think maybe just putting a little asterisk and pointing people to the appendix where we define things would work. Whatever, just jump on in, join the group. It's open to everybody. You also could listen in on a meeting. They're all put onto YouTube afterwards. So you could see if you want to try and attend a meeting in the future. It may not work with your work schedule or whatever, but if you can, the meetings are open to everybody to attend. And we publish the agenda in advance, so you can check that out. And then I'm halfway through, but I'm done my talk because I'm from Philadelphia and talk fast. So we're going to recap, and then people can ask questions, or I can get into vulnerability disclosure programs if anyone wants. All right, so recap. This is a framework. It's not a tool. It is not another scanner that you're putting in there. It is just a checklist of standards to give a common terminology and an achievable laddered approach to have integrity and security of build processes and external packages so that there's resiliency all along the software supply chain. You should care because right now there has been an exponential increase in software supply chain attacks because it is easy. Because more than 50% of the code that most people are using was not written by them. That is not a bad thing. Everyone's like, oh, well, maybe we just write our own code. No, the reason why today we are able to deploy software so quickly is because we are leveraging open source, which is great. But that comes with risks, so there's a trade-off. Go fast, have a little bit more risk. So how do we mitigate those risks? And also government requirements are kind of coming. They may not hit your industry yet, they may not affect your company yet, but sooner or later, because it's becoming standards, you are going to get impacted one way or another. As a software producer, you want to produce attestations, and you want to verify any of the attestations of the tools you're using by setting in a policy. You probably have policies at your workplace already. For example, do not use GPL. Or maybe you're at an awesome place that allows GPL, whatever. But you probably already have some rules that you have to check when you're using these dependencies anyway. Just add it as an additional rule for when I'm pulling these into my artifact repository, my JFrog, whatever. This is another thing to check. If you're just a consumer, if you're not distributing, all you have to do is do the verification. And again, there's SLSA verifier by the OSSF. You could write your own. It's not that complicated. And there are lots of free tools to help you out with both production and verification. All right, so do we have any questions? Yeah.
Yeah, so you got a development team, right? And you got to allow you secure and everything, design your application securely. Like, how do you approach them to adopt the framework? I mean, because typically they're... Yeah, so the question is you're working with the development team and you say, yeah, you know, you want to design your application securely, or are you doing all these things, and they get their hackles up. Like, how do you approach them to get the adoption of this?
So the thing is you want to try and make it as minimal for them as possible, which is going to be more work on either your DevOps team or your security team. So you have to find one team which is willing to take the hit. So if you can, for example, use some SCA tool, or maybe you've got GitLab, which has SCA tools built in, you're like, hey, there's going to be this automated check which occurs for your dependencies, and I've turned it on to check the licenses, the vulnerabilities, and that there's an attestation. And it's going to put a comment in your PR. Don't start by having it block anyone. Okay? Again, laddered approach, start at the very bottom. Just be like, it's just going to warn you that there's stuff we don't like in there. And we would like you to try and work around it if you can. For example, if there's a vulnerability in the current version you're using, and you look, could you just go down one version or up one version and make it go away? Or if there's no attestation, can you double check that it is not typoed? Or would you mind if we proxied everything so that we could actually have the security team go through once a week or once a month to make sure none of these were typo squatted or known bad, because then they could cut it off of the proxy and be like, no, this specific one's blocked because we figured out it was bad. And then once everybody kind of gets, it's boiling a frog in water, once everybody gets used to that and it's not bothering them, they're like, okay, it wasn't so bad, then you can kind of crank it up a little and be like, hey, if it has a critical vulnerability, and it's going to one of our production systems, we are going to block it, and you're going to have to get a manager to sign off, but then it can go if you want. But again, you could like go down a version or up a version or whatever, and like here's ways to mitigate around it. So you just keep slowly dialing it up, because you're right, if you make the development team frustrated, slow them down a lot, it's not going to work out. But you need to show them like, hey, it's not so bad, and here's quick remediation steps, and here's quick ways to get around it, so that you and I don't have to have a conversation every month for like, why do you have 20 criticals? Or why do you have like 10 things that are not from NPM? Or they're not from PyPy? Like, why did you just go YOLO it off of, you know, SourceForge? Anybody else? Uh-oh.
Thank you. Hi, Nicole. How would I put it? One of the things that is frustrating sometimes for me, being kind of a blue team guy with the government, is a lot of the work that happens, good work that happens, is done on a volunteer basis, off hours, kind of like what you're doing right now. For people who don't know, we're establishing Cyber Alberta right now, community of interest, try to actually strengthen the overall cybersecurity for the province. One of the next thing we're about to do is establishing some kind of an Alberta base to start with. Who knows, it might become national. Set of I'm going to call it controls, a compliance framework. We want to work with the community of interest to do it. It's not government coming and saying, thou shalt do the following things. It's really something we want to work with the community of interest to establish. You get the control framework, wonderful. Now, how do we implement it and such? And I'm looking at what you're presenting today saying, this would be a fantastic framework to implement across the province for your development efforts. How do you and the group you're working with promote this framework? And would it be helpful to count on an organization like what we're setting up right now, this 250 members plus organization right now, to try to promote implementing a framework like this, that at the end of the day would be extremely useful? Like, how do you do it today? How do you do it today? And this is why I take offense to the boiling the frog comment. Sorry for the accent, but but how do you see it expanding? Would Cyber Alberta be something that could be helpful if you were to come in and do a presentation? Like, that's kind of my question.
It very much
long-winded.
We've tried presenting it to groups so far, but there has not. It's a little bit of a problem where right now we're trying to get people to be producing these so that people can verify them, but there are not a lot of producers, and so a lot of times you're just going to end up with the verification step being like, I couldn't verify there wasn't a file there, which is why we're really excited NPM is all in. And so until we get more of the package managers, it may not help you out a ton yet. So right now we're mostly reaching out to like maintainers of open source software. So if you have anyone who does maintain OSF stuff, like, absolutely tell them like, hey, this is really easy, you can plug it into your GitHub, because once there are more of these out there, it'll be easy to verify it. And we are happy to do presentations wherever, and the working group, like I said, you can just pop into the GitHub. You don't have to participate in the meeting, so everyone can put as much or as little time in there as they want. But honestly, the hope is that this framework, like you said, somebody could write, like, here's how you implement it using JFrog. Here's how you implement it using GitHub. Here's how you implement it using GitLab. And then it just becomes a turnkey thing. Like SCA used to be a bespoke do-it-yourself adventure. And now it's pretty turnkey. You just buy something, plug it into your CI/CD, you're done. That's what we're kind of hoping for, is it just becomes another framework piece where it's like you pop in this framework and it just alerts you for these key things. You can turn the knob on that and be like, I want to be alerted only if it's really bad or all the time, depending which software project where it's going.
Hi, Nicole. Is it okay if I change the topic to women in tech?
Sure.
So, several years ago, in the early days, it was probably a year or two of Edmonton BSides, I came to your talk and spoke to you afterwards about how dismayed I was that I think I had less than 10, I work for a global IT firm, and we had on our security team less than 10% female identifying staff.
Not unique.
Not good, not unique. You gave me some advice on wording job ads. That, you know, obviously there's tons more you can do. But I'm happy to report that probably it took 3, 4, maybe even 5 years. I don't know how long ago that was. But we've now got our female headcount up to 45%.
Yes.
Spanning both Canada and the US.
Awesome.
So thank you. Your advice works. Anyone else who has the same problem, talk to Nicole.
I've got like loads of tips and I'll just put a quick plug. It does not matter what your role is in a company. If you tell me what your role is, I can tell you how you can make an impact for DEI, not just for gender parity, but like how do you make sure that you're treating parents well? Because parents get shafted a lot because it's like, oh, well, they always leave at 4:30 to pick up their kids. Should we give them projects? Yes! Give them the stretch projects. But anyway, wherever you are in the company, I can give you advice and or yell at you. Yep.
One more question, Nicole. My name is Michelle Balderson. I'm from ISS Squared. I've been in the security industry for probably 25 years of my life. I'm getting too old to exactly remember, but 25 years of my life. And one of the things that we have is an extraordinary number of frameworks coming out, right? Every single government wants to build a new framework. No slide against Cyber Alberta. But from a global perspective, we have, you know, ISO, we have IEC, we have tons and tons of frameworks. So the question relative to this, and sorry, those main frameworks that I talked about are very hard to adopt, let alone a software cycle framework that you're talking about. Is there plans of taking this framework and bringing it into IEC or other frameworks? Because then at that point, making it a sub-part of a core framework that we could use based off of industries would make a lot of sense. Is there any plans for something like that?
No, but so because they're all owned by different groups, there is no plan to harmonize them right now. But right now, specifically with SLSA, and then I can also talk to a couple other ones, SLSA actually covers a subset of the SSDF. And so if you do SLSA, you actually accomplish a chunk of the SSDF, and then you only have a small bit left. And I know in version 0, we were kind of advertising that, but I'm not sure that we're still advertising it. And so there are definitely some people I know who love making spreadsheets because they're my people. And my hope for a lot of stuff is that if you look at, for example, there's like the ISO and a couple others, and I've looked at them. When you accomplish one, you're actually accomplishing a subset of another. And what I think would be really nice, and I don't know if anyone officially would do it, but maybe I should get some people to unofficially do it, is say like, hey, by the way, if you have to comply with these 3 or 4 frameworks, we suggest starting with this one because it'll actually get you, you know, half of the way here to this one, and then you can do this one. So everyone does talk, and a lot of people are on multiple different working groups. Like, for example, there's a lot of overlap with SBOM in SLSA, and you can actually use an SBOM as one of your SLSA attestations. So if you started with SBOM, hopefully you did, bam, you've got a whole chunk of your SLSA done. And so they really are, we're all trying to cooperate such that they're stepping stones instead of just these completely disparate things, but nobody's actually published a guide to that because there is no organization who wants to piss off all the organizations. So, not helpful, but there's the answer. Thank you.
Thank you. Thank you, Nicole.